In this video, we're going to solve 1992 FRQ question 2. It's fairly simple, a little bit annoying, but it's not hard. It says a particle moves along the x-axis so that the velocity at time t, 0 is less than or equal to t, which is less than or equal to 5, is given by v of t equals 3, t minus 1, quantity t minus 3 at time t equals 2. The position of the particle is x of 2 equals 0. Find the minimum acceleration of the particle. Okay, so in order to find acceleration, you need to take velocity and take the derivative of that. So part A, velocity is the function given to us, 3t minus 1, t minus 3. It's easier to take the derivative if we FOIL this. We could do a product rule, but I don't really want to do that. So t squared minus 4t plus 3. So v of t equals 3t squared minus 12t plus 9. So a of t, that's acceleration, is equal to the derivative of v of t, which is 6t minus 12. Set that to 0. So 6t equals 12, t equals 2. Let's test. So here's 2. Pick a number less than 2. 0, 6 times 0. 0 minus 12, negative. Plug in a number bigger than that. 6 times 3, 18 minus 12, positive. So at t equals 2, there is a min of negative 12 because acceleration changes from positive to negative. Negative to positive, not other way around. Otherwise it would be max. Okay, part B. Find the total distance traveled. Okay, so if we want to find the total distance traveled, probably easier to integrate this, but we're going to have to integrate this into several parts. So that's right. V of t equals, don't get ahead of myself, 3 t minus 1, t minus 3. Let's just put a number line here. Here's 1, here's 3. Pick a number less than 1. 0.5. 0.5, negative, negative, negative times a negative, that's positive, so no problem there, that's positive distance. Okay, let's pick a number between 2, positive, negative, ooh, that's negative, that's going to be an issue. Pick a number bigger, 4 minus 1, positive, positive. Okay, so when we do this, we're going to have to integrate. And we're going to want to use this function over here. So let me just move this. Going to need a lot more room. A lot more room. So distance is going to equal the integral from 0 to 1 v of t dt plus the integral from 1 to 3 v of t dt plus the integral from 3 to 5 v of t dt. Or you could do absolute value, but I don't know if this is a calculator question or not. So distance is going to equal, what's the antiderivative? It was 3t squared, so the antiderivative is t cubed, and it was 12t, so 6t squared, and it was 9, so plus 9t. Okay, so 0 to 1, and this should be a minus, not a plus, because of that. So you get positive area. Okay, almost messed up. T to the third minus 6t squared plus 9t, what was it, 1 to 3, plus, same thing, just annoying work. plus 9t. What's that? 3 to 5. So plug in 1. You're going to get 1 minus 6 plus 9 minus 0 minus, plug in 3. You're going to get 27 minus 54 plus 27. Use parentheses. Minus the 1 minus 6 plus 9. Plus, what's that? 125 minus $1.50 plus 45 minus 0, because that part's 0. I can tell that. So that's going to be 0. Okay, so let's do the math. 1 minus 6, negative 5, plus 9. What's that, 4? Minus 1 minus, that's negative 4. Now we have positive. Now what's that, 170 minus 50 is 20. So the distance is 28. Okay, so now the next part of the question says, find the average velocity of a particle over the interval 0 to 5. So we got to do 1 minus b over a. So average velocity, part C. Average velocity is going to equal 1 minus b minus a, integral 0 to 5 v of t dt. So 1 over 5 minus 0. And we already have the 5 from right here. So we're just going to steal that information. So it's 125 minus 150 plus 45 minus 0. So your average is going to equal 20, I believe, no, 20 divided by 5. Yep, so 20 divided by 5, which equals 4. Okay, and I hope this video helped. Amen.